Determine the work done by an ideal gas during a closed cycle. Okay, so we have a closed cycle starting from 1 to 4, and from 4 to 3, and from 3 we have 2, and from 2, okay, finally we come to the initial position, that is 1. Shown in figure, if P1 equals 10 power 5 Pascal, P0 equals 3 times 10 power 5 Pascal, and P2 equals 4 times 10 power 5 Pascal, and we have V2 minus V1, okay, difference in volume, equals 10 liters, and segment 4, 3 and 2, 1 of the cycle are parallel to the V-axis, that is volume axis. So we can see in this question and diagram that we have a closed cycle, clear, and we have a PV diagram, and we have pressure in Pascal. Okay, so we have pressure in Pascal and we have volume in liter. So we need to understand this, and in order to solve this numerical, okay, we use this concept, work done by a gas, okay, gas during the cycle is determined by the area of the PV, okay, area of the PV diagram bounded by the cycle. Since we have a PV diagram, okay, so in order to determine the work done during a closed cycle, okay, we need to determine the area of the PV diagram bounded by the cycle, and we use sign convention, okay. We take work done positive, and we can take work done as negative, okay. So in order to take work done positive and negative, we follow this sign convention, okay. If the loop is traced, okay, suppose if we are moving in the loop in clockwise, determine the work done by an ideal gas during a closed cycle, okay. So we have a closed cycle starting from 1 to 4, 4 to 3, and from 3 we have 2, and from 2, okay, finally we come to the initial point or position, that is 1, shown in figure. If P1 equals 10 power 5 Pascal, P0 equals 3 times 10 power 5 Pascal, P2 equals 4 times 10 power 5 Pascal, and V2 minus V1 equals 10 liters, and segment 4, 3 and 2, 1 of the cycle are parallel to the V-axis, that is volume axis. So we have a PV diagram, and from question, okay, we can see that pressure is expressed in Pascal and volume is expressed in liter. And we know, okay, 1 Pascal equals 1 Newton per meter square. So we have this, okay, and 1 liters equals 0.001 meter cube, or in CGS we can write 10 power 3 centimeter cube. So we are going to use these conversion, okay, if necessary in this problem, and we are going to use this concept, okay? Work done. Since we have a PV diagram, okay? And in case of PV diagram, work done by a gas during the cycle is determined, okay, by the area of the PV diagram bounded by the cycle. So we have to find, clear, the area of the PV diagram bounded by the cycle in order to find or determine the work done by the gas during the cycle or closed cycle. And we use sign convention, okay? So I'm writing sign convention. So we take or we follow this sign convention, okay? If the loop is traced or if the loop is moved, okay, traced clockwise, okay, direction, that is we are moving in closed loop in clockwise direction, then work done is taken positive. So we have this. And if the loop is traced anti-clock, okay, anti-clockwise direction, that is if we are moving in the loop in anti-clockwise direction, then work done is taken negative. So we have this. So we are going to use this sign convention, okay? And we are going to use this concept while solving this numerical problem. Now, we have a closed cycle, okay? Closed cycle starting from 1 to 4 and from 4 to 3 and from 3, okay, we have 2 and from 2 finally we have 1. So is made from 2 closed cycle. Clear? So one, we have this, we have cycle 1 to 0, and from 0 we have 2, and from 2, okay, we have 1. Now we can see, okay, this cycle and this cycle. So I'm drawing over here. Since we are moving from 1 to 4, okay, so we have this direction for 1 to 0, okay, and we are moving from 3 to 2, okay, it is given in the figure. We are moving from 3 to 2, so we have this direction, okay, so we need to note this. So we have this, since we are moving from 1 to 4, so we have this. Now what you find in this case, okay, In this case, we are following or we are tracing the loop. We can see we are tracing the loop in clockwise direction. So we are tracing the loop in clockwise direction. So the work done in this cycle is positive. So we have positive work done. And next, okay, we have cycle, okay, starting from 0, okay, 0 to 4, and from 4 to 3, okay, and from 3 to 0. That is the starting position or the initial point, okay. So we have this. And for this cycle, okay, so I'm writing in this way. For this cycle, we have this, okay. We have 0. This is 0. And from 0, we move to 4. And from 4, we move to 3. And from 3, we move to 0. So we are moving in this direction. Clear? We are moving in this direction. So what we find? We are following anti-clock. We are following anti-clock. So work done, okay, for this cycle is negative. So we have this. Clear? Now, when we look into this figure, okay, we find there are two triangles. Clear? What do you find? We find there are two triangles. So we have this. Clear? We have this. And we have this, okay. This is 1 labeled as 1. This is 2. This is 3. This is 4. And this is 0, okay. And this is V2. So we have this. As I said earlier, in order to find work done, we have to find the area of the PV diagram. Let's say we are going to find work done, okay, for this closed cycle. Clear? So to find work done, we have to find the area of triangle, let's say 0, 1, 2. So I'm writing in this way, okay. And this equals half times its base times its height. Okay. So we have to find its base. And we know this is origin, okay. This length is V2. This length is V1, okay. So the base of this triangle, so it is this length, okay. So this length represent the base, and the base is V2 minus V1. So we have this. Clear? Now in order to find its height, okay, so we have this, okay. This is the height. This is the height of the triangle. So to find this, okay, what we do, we can see this is P1, okay, and this distance, okay, vertical distance is P naught. So when we find the difference, okay, when we find this difference, okay, so this gives me, so this difference gives me the height. So the height is P naught minus P1. So we have this. So this is to be noted, okay. So what you find, area of this triangle, okay. So I'm writing triangle 0, 1, 2. Please don't get confused, okay. So I'm writing in this way. So we have this, okay, half times base is V2 minus V1 and height is P1 minus P0. So we have this. Now, for triangle, okay, so I'm redrawing this figure once again. For this triangle, okay, we are going to find it for this triangle. Let's say for this triangle, okay. So we have P and we have V and we have this. This is P2 and this point is 3 and this is 4, okay. So we have this and this is 0, okay, and this is P0. This is P0. Now, what we find for this triangle is that, okay, and this is P1. So we find for this triangle, okay, we have pressure and volume, okay, marked. So I'm writing for triangle 0, 1, 2, okay, the values of pressure and volume are marked or given, okay, in the question. So for this, okay, due to this, we can determine its area, okay, easily. So we can find its area, okay, easily. So I'm writing in this way. Clear? We can find its area directly or easily. Now, when we look this triangle, okay, so I'm writing over here. For triangle, so I'm writing 0, okay, 4, 3. So we have this triangle. Only, okay, the values of pressure, we can see we have 0 and the pressure corresponding to 0 is P0 and the pressure corresponding to 3 and 4 is P2. The value of pressure are marked or given. But what we find when we look into the figure, okay, the value of volume, okay, corresponding to 3 and 4, Okay, but value of volume corresponding to 3 and 4 are not marked or leveled. Okay, though we can see, okay, the volume corresponding to 3 is this, the volume corresponding to 4 is this, but there is no distinct mark or marking of volume corresponding to 3 and 4. So in order to find the area, okay, so I'm writing over here, due to this, we determine the area of triangle 043, okay, 43, with the help of triangle 102. So we cannot directly find the area of triangle, okay? We cannot directly determine the area of this triangle. So I'm writing area cannot be directly determined, okay, using the formula half time base times height, okay, so times height, so using this. So for this reason, okay, so for this reason, for this we use the concept, okay, we use the concept. So I'm writing over here. Now what we find, we use this concept of geometry, okay, concept geometry, ratio of area, okay, of triangles, triangle or triangles, okay, so I'm writing in this way, triangles equals square of the ratio of any pair of the corresponding sides. Clear? Now, since we know pressure corresponding to 0 and pressure corresponding to 3 and 4. So we know the vertical height, okay? We don't know the exact marking of volume corresponding to 3 and 4. So we are taking corresponding side, okay? So any pair of corresponding side. So for this, okay, we are taking the vertical height. So I'm writing in this way. So we have vertical height, clear? So I'm writing in this way, area of triangle, we have 102. So we have triangle 102, okay, divided by area of triangle 0, 4, 3. So this equals, now as I said earlier, square of the ratio of the corresponding sides. Now we are taking the height, and for this, okay, for this triangle, okay, the height is P0 minus P1, okay, and for this triangle, okay, for this triangle, so for this triangle, the vertical height for this triangle, the vertical height is P2 minus P0. So we have P0 minus P1 whole power 2 divided by P2 minus P0 whole power 2. Clear? Therefore, we can write area of triangle 0, 4, 3 equals, so from this, okay, area of triangle 1, 0, 2 times we have P2 minus P0 whole power 2 divided by P0 minus P1 whole power 2. So we have this. Clear? Therefore, as I said earlier, we use the concept of work done. Clear? We use the concept of work done. So we have this area, okay. So we are going to use this concept, work done equals area. Now we are going to determine work done during this cycle and work done during this cycle. And what we know is that work done during this cycle is negative, okay, since this loop or path is traced in anti-clockwise direction, and work done during this cycle is positive since it is traced or is traveled in clockwise direction. So we have this. Now case 1, okay, for cycle 1 to 0 and from 0 to 2 and from 2 to 1, okay. So for this cycle, I'm writing in this way, work done 1, 0 to 1. So this equals half time base. So we have this, okay. We have this half time V2 minus V1 times P1 minus P0. V2 minus V1 times P0, okay. So we have P0 minus P1, and this work done is positive. This is positive work done. Why? Because the loop is traced. Loop traced clockwise. Clear? So we have this. Now, next, okay. Case 2. For cycle, okay, 0 to 4, and from 4 we have 3, and from 3 finally we have 0, okay, for this cycle. Clear? Work done. So I'm writing in this way, 0, 4, 3, 0. So work done, and we know this loop is traced in anti-clockwise direction. So the work done is negative. So we can write plus over here also, okay? In this way. So we have negative, and work done equals area. So area of this triangle, okay, is this. So we have area of triangle 1, 0, 2. So we are using this formula, okay. So we are using over here, clear? So area is half times V2 minus V1 times P0 minus P1, okay. And we have P2 minus P0 whole power 2 divided by P0 minus P1 whole power 2. So we have this. Now, what we do is that, okay, we have to find total work done. Clear? We have to find total work done. Clear? So let us call it equation 1, and this is equation 2. Now, total work done. So we have this. Okay, we are moving from 1 to 4, and from 4 to 3. Okay, and from 3 we go 2, and finally we come to 1. So this equals, so we can see from the figure, okay, we have this. This is 1, this is 2, this is 3, this is 4, and we have 0, okay. And we have this direction, clear? We have this direction. So we have this, clear? And this work done is positive, and this work done is negative, okay. So we have this. So total work done equals, so we can write in this way. So we have this. Therefore, we can write, okay. So this equals, now we know work done in cycle 1021 is half times V2 minus V1 times P0 minus P1. So let us write it, okay. So we have half times V2 minus V1 times P0, okay. So we have P0 minus P1, and since this work done is negative, so we have minus, so half. So we have this. Let's see. We have this, okay, equation 2. So we can cancel this also, okay. So we have minus 1 by 2 V2 minus V1 times P2 minus P0 whole power 2 divided by P0 minus P1. So I'm writing over here, okay. V2 minus V1, okay. So we have this P2 minus P0 whole power 2 divided by P0 minus P1. So we have this, clear? Now, what we do is that, okay. So I'm writing in this way. Let us take this common, okay? 1 minus, clear? Now we have this. So we have this, clear? So we get this, clear? We can write in this way also. So we find this, clear? On doing simplification. Now, V2 minus V1. So from question, okay? V2 minus V1 is 10 liters. So we have this. And we know 1 liter equals 0.001 meter cube. So I'm writing, okay? 10 times 0.0, okay? 01. So I'm solving the numerical in SI system, okay? And we have P naught given in the question, okay? We can see this is P naught, and P naught is 3 times 10 power 5 PA, okay? And we have P1, this is 10 power 5 PA, we can see from the question, okay? See, we have P1, P0, and P2. P2 is 4 times 10 power 5 Pascal, okay? So we have this. So P2 is 4 times 10 power 5 PA. So we can find the difference, okay? P0 minus P1. So we have 3 times 10 power 5 minus P1 is 10 power 5, okay? So we have this 1 minus. Now I'm writing in this way, okay? P2 minus P0. So we have 4 times 10 power 5 minus 3 times 10 power 5, okay? And we have P0. P0 is 3 times 10 power 5 minus P1 is 10 power 5, and the whole power is 2, okay? So I'm writing in this way, clear? Now, when we simplify this, okay? So I'm writing in this way, okay? Work done during the whole cycle, okay? So we have this, clear? Now on simplification, okay? On simplification, we get this, okay? And this will give us 1 minus 0.25. So we have this, okay? So we have this, or let me write in this way, okay? Times 1 minus 0.25. So we are getting this, okay? And we get 1000 minus 0.75. So the total work done, okay? Work done. So we have this. Equals 750 joule. And we are getting total work done positive. We are getting this positive, okay? So this is to be noted.